this is Charlene. We are going to find the domain and range of this quadratic equation. Well, how do we know that it is a quadratic equation? Well, the highest power on our variable x is a 2. Anytime you have y equals x squared in your equation, this always indicates that it's a quadratic. Okay, so we should recognize a couple of things about the domain and range of all quadratics. Let's look over here at our Desmos screen that I've pulled up. You can go to desmos.com and you can put in our equation here. If you notice, I've already done that. Y equals negative x squared plus 3, y equals negative x squared plus 3, and we can see our graph here. Let me get rid of this stuff. Don't need that. Okay, so this is what our graph looks like in Desmos. So I don't need this anymore. Let's move that out of the way. But let's pull up just the graph part. Okay, so our domain includes all of our x values. So the domain are the x values. The range includes the y values. So the domain, because it's x values, this has to do with left to right. So where does our graph go? It's going to keep going forever down this direction. It's going to keep going down forever this direction. It's going to keep moving to the left. It's going to keep moving to the right. And it's going to go on forever and ever and ever. So our left to right movement, which are our x-axis values, is going to be from negative infinity to positive infinity. That is the domain. Another way of expressing that is an interval notation, but another way to say that is all real numbers. And we can use this symbol to represent all real numbers because it will go on forever this way, it will go on forever that way. Okay, so now let's think about our y values. Our y values are the range. That is the up and down movement of our graph. Okay, so that means where does it start? Where does it start? And where does it go to? Okay, well, what's down here? Where is this graph going? Where is it starting down here? From where is it starting? Well, again, it's going to be from negative infinity because these are all the positive values in the y-axis. All the negative values of y's values are in the lower quadrants. So it's going to start at negative infinity and it's going to go up to this point. Well, what is that point? Well, there's 1, 2, 3. And that is also reflected in this number right here. Our plus 3 is the top, the maximum of our quadratic. And of course, this graph that we have drawn is called a parabola. It's called a parabola. And the top of our parabola is the maximum, and it's also where the graph stops. It does not live or go anywhere above that. So it starts at the negative infinity, and it goes to the number 3, and then it stops right there. So it's going to be from negative infinity to the 3. It stops at the 3. And another way to look at this is that the negative infinity is less than our y values, which is less than or equal to the 3 where it stops. Okay, so that should answer the question about the domain and range. Our other extra question over here is it a function? Well, can we draw vertical lines through our graph at any point? If we draw vertical lines, how many times does it hit it? It only hits the graph right there one time, hits the graph right there one time, hits the graph one time right there, hits the graph, well, I didn't draw that straight, one time. So as long as the vertical line test only hits the graph at one point, anywhere where we draw a vertical line, then that qualifies it to be a function. Is it a function? Yes. So quadratics, which are of the form x squared, are always functions. Yes, they are always functions. And the domain for a quadratic is always all real numbers. Your range is going to be where is the maximum or where is the minimum. And so this has a maximum at 3. Okay, hopefully that helps. And come back and see us again. Click the like button, subscribe to the channel.